All right, well, welcome everybody. We're so glad to host you today. While we're getting started, I would love it if you could put in the chat where you're joining us from today, because I happen to know we have at least one person who is not in the US, and then we have lots of closer to me people. I'm in New York. Let's see. Look at this. Welcome, welcome. What a good group. So we've got lots of different places. I see New York, Rhode Island, Florida, Washington, Texas, Connecticut, Portugal, Alabama, Tennessee, Missouri, Massachusetts, Pennsylvania. Awesome. So great to have all of you. So we are going to start in just a moment. We're just giving everybody a chance to get themselves all set. And then we will get going, and we'll make sure that we have plenty of time to learn about oysters and microplastics, but also plenty of time to get your questions answered, because I bet you guys have some questions. I know some of our scholars have been working on oyster dissections. Is that true? I heard the rumor that that might be true for some of you. Oh, okay. I see some thumbs up. Yes, Miss Larkin's class. Awesome. All right. Well, welcome everybody. Just wanted to say hello from the USA Blue Schools for my teachers who are not aware of the USA Blue Schools. We are a network of schools that is now growing pretty quickly. We're hoping to get more schools throughout the US. And these are schools who are committed to improving ocean literacy for their students and families and school community. And who want to engage kids in action projects to help our global ocean. And we are a part of the All Atlantic Blue Schools Network, which has 18 countries up and down the Atlantic Basin. So you can see some of our countries on this map right here. And so we are really lucky today to have Dr. Kayla Poole with us, who is going to share with us some of the research that she's done around oysters and microplastics. I'm going to encourage you all to keep yourselves muted for now, just so that we can hear Dr. Poole better. But teachers, if you have questions coming in from your students, please feel free to put them in the chat. And when she finishes her talk, we'll throw some of those questions at her and get them answered. And I know that we have some very curious learners online, so we definitely want to make sure we get those questions answered. So Dr. Poole, I'm going to turn it over to you.
Hi, everyone. I'm Kayla, and I'm not a doctor that you would go visit if you had a cold, but I am a doctor in marine science. So I like to think of myself as an oyster doctor. And I did a lot of work looking at different filter feeders in Long Island Sound to get that title. And we're going to talk about that today, how they interact with plastics. So just so you understand how the presentation is going to go, we're going to talk about the plastic pollution problem that we have, define what a microplastic is, and what the fuss is around filter feeders. Then we'll go into some of the laboratory experiments that I did, looking at how different filter feeders, like the animals pictured here, handle microscopic plastics, so teeny tiny plastics. The groups are divided into selective feeders, which are here. So you can see the oysters in my hand pictured here, and the mussels to right next to the oysters. They tend to be really picky eaters, actually. They can eat and reject, which means to spit something back out, particles that are really, really tiny, but they tend to eat little plants that live in the water called phytoplankton. And then we have our not so picky eaters that also filter their food from the water. And those are the snails, which form ducks right there. They're called slipper snails, and sea grapes, which are also called, they're a type of sea squirt. So when you squeeze them, they squirt water back out at you, but don't squeeze them. And then we're going to talk a little bit about what we see in Long Island Sound, because I know that some of you are from New York, so I have to always give a shout out back to my Long Islanders. So here are some important definitions for you to understand. A microplastic is a piece of plastic that's really small, something smaller than a paper clip. And a particle is anything small enough for animals to eat. I will use the word filter feeder and suspension feeder to mean the same thing. Those are animals that get their food directly from the water. They can suck water into their bodies like a vacuum and catch the little particles on their gills. They eat these particles and then they poop them out. So we call that feces if you want to be correct about it, but we'll just call it poop for now. And then we also have pseudo feces, which roughly translates to fake poop, and that's what they spit back out. So when they don't want to eat something, they wrap it up in mucus or snot, and then they spit it back out of their bodies, which is pretty fun. And then finally, a bioindicator, which is what I was looking for, is an animal that you can use to measure the amount of microplastics in the environment so that we can figure out how many microplastics are there and what the issues are. So what's the plastic problem? I'm sure a lot of you have heard about plastic waste as a major problem. In the US alone, millions of tons of plastic waste end up in the environment. This graph shows the dotted line, which is the amount of plastic produced in the US over time. And then the solid red line is the amount that ends up in the waste stream and landfills, so at the dumps. It's thousands of tons, so that's a lot of elephants if you want to translate it roughly. Further, the US does not have the proper ability to handle the amount of waste, with very little of it actually being recycled. And you can burn some of it for energy, but we don't do a lot of that because that also creates a lot of issues. So plastic waste gets into the environment through a number of pathways. There's littering on the shore, which you'll see when you're driving. You might see trash along the roadways or at the parks. And then that gets washed into the waterways via storm drains, rivers, and streams. And then out on the ocean, there can be accidental loss when boats are shipping goods between different places. And you can also have fishing gear that gets lost or broken out in the ocean, and that creates a lot of issues for larger animals such as whales, or dolphins or anything along those lines that can get tangled up in that plastic. Sometimes they also, like sea turtles, can mistake plastic bags as jellyfish, which they eat. So they might accidentally eat a plastic bag, which is very bad for them. And then what we're going to be talking about today is how these plastics get beat up in the water and they break down into really microscopic sizes, which are microplastics. And those can be spread throughout the ocean. And many end up trapped in currents in the middle of our ocean, making sort of a plastic soup that can go for miles. And the problem isn't just about the tiny particles or the cost to larger animals, but what it's made up of. So hydrocarbons are what make up the oil that your parents put in the car, and also makes up plastic. And it's pretty bad for the environment. And the amount that's released would be equivalent to the 9 largest oil spills in history. So it's actually a climate problem as well. So with all this in mind, it's really hard to keep track of these tiny plastic pieces. Mussels have been used for decades, which are these black guys here, to monitor pollutants in the water, like heavy metals such as mercury. And we know that they can eat microplastics, so many have suggested that we use mussels or oysters to track microplastic pollution in the water. So I made a list here to determine what we would need from these animals in order to be able to track plastics in the water. So first of all, we have to be able to find this animal everywhere if we're going to use it to monitor what plastics are across our world's oceans. which they are. They need to be easy to collect, which these animals don't move. Once they've picked a rock to live on, they stay there for the rest of their lives. And then they need to feed actively. So they need to be filtering the water all of the time and be eating whatever comes out of the water. And you need to see the same types of microplastics in the environment that you see in the animal. So for example, if you were to use the mussel to monitor what was in the water, the orange circles, you would see the same plastics in the water that you would see in the mussel. And or if you were to use use the oyster to monitor what was in the sediment on the bottom, you would at least be able to tell how much plastic is in that environment based on what you see in the animal. The issue here is that, like I said, oysters and mussels are actually really picky eaters, so they won't eat everything that they interact with in the water. So now what? So I'm going to walk through some of these experiments. I gave oysters and mussels, which are in the top box, there are picky eaters, and snails and sea grapes, which are in the bottom box. These are our non-selective filter feeders, which means that they don't tend to be picky and they tend to eat what they interact with. So maybe that they would be a better bioindicator species. Maybe we could use them to monitor plastic pollution. So let's talk about how these animals eat. So let's start with the picky eaters. This is a diagram of an oyster. And if you took the top shell off that we were looking at, this is what they look like on the inside. And I know that some of you have done an oyster dissection, so you've seen this. So all filter feeders pull water into their bodies, see those blue arrows, and catch those particles on the gill here. They can move the particles up and down their gill along these little tracks like a train. And then at the top, by that red arrow, they have a special selection site. So here is where they either ball those particles up in mucus and spit them back out, or they carry them to the mouth. Oysters are special because they can also do this on the gill. Mussels can only select what they want to eat right before their mouth, but oysters can also do this on the gill. They have very fancy gills. Oops. And so I put this little video in here, and we're just going to skip through it quick. That shows mussels. So we have a technique where if, probably haven't heard of an endoscope, but it's a little microscopic camera that surgeons use to see what's wrong when they can't tell from x-rays or anything else. And so we use this little microscopic camera to look at what's happening inside of the mussels and oysters. So this is those frills around the mussel's mouth opening. And this is where they were pulling those particles in. So you can see the water flow. You can see these little pieces moving in the water as they pull water in to their bodies. Let's skip ahead. This is what that gill looks like from the side that we were looking at for the oysters. And I want you to look at what happens when you're going to see a bunch of green little beads fly into the image. And this is the gill, what the actual gill looks like on the oyster. So here's that gill, and that's the top there. And you can see these little things moving along the tracks of the gill. So they catch it on their gill and they move it to the edge of the gill. So this is moving like across the gill that way. I think is this bridge. So they transport all of those particles to the edge, and then it gets carried along that edge up to here, which is where the mouth is. And so they actually have really cool mechanisms that they use to feed in the natural environment. And you just see those particles moving within that groove, which is pretty cool. So let's talk about snails. How do these snails eat? So if they're stacked like this on top of each other, this is how they live their lives, stacked on top of each other. They create little families. And when you take that shell off and flip it over, this is what the animal looks like from the bottom. This is their foot, which they use kind of as a suction cup to stay attached to the shell below them. And if they turn their head, this is their gill behind their head. So I just want you to be able to see that from both sides. What they do is they pull water in on this side, catch it on their gills, and then carry it across to a really funny feeding tactic where they wrap up that food in a cord and put it in their necks. Then they can pull food from their necks like a little snack pack and eat from there. Or if they don't want it or they're too full, they'll push the food into this little pouch in front of their mouth there. This is their little cheeks and their little mouth. I think they look like an adorable little sea cow. And this is where this is that pouch in front of their mouth, just bigger so you can see it. And whatever they don't want to eat, or they push out of that pouch, and then they poop right next to their faces, which is a very silly mechanism, but sometimes they eat their own poop too, which is a little fun fact. Okay, so I want to show you what we do. So this is that microscopic camera. We let them suction cup themselves to a plastic flat piece with slits in it so that we can fit the microscopic camera in. And then this is the view of their face with that little pouch in front of it there. And that's their tooth. It's called a radula. So they have a fancy little tooth, and that's what they use to eat. And so you'll see food come up from the side, but you can see right here, they're spinning around. So this is that food cord that I was talking about. That's up in their neck. And then they pull from that to eat. And then whatever they don't want goes into this pouch right here. We gave them some pretty big plastic beads to see what they would do with these. And you can see that they push most of them forward, but there's a few stuck in their neck, and they do try to eat them. They don't really care. It's just that they can't fit them in their mouth. That's really the biggest issue here. See, he's trying to eat those plastic beads. And you can see he's trying to eat them, and then he pushes them forward. So that's what we would consider rejection, because he doesn't want it. Or he's just too full because we gave him too many plastic beads to eat. We also did this, so you can see sometimes the beads don't even make it to their mouth. They just go across the gill along the back here and get immediately rejected because it's just too much. He's got one stuck to his cheek there. And then that's them being pushed out. And then we also gave them long black fibers, which you'll see in my experiments, to see how they handled something that was more like a piece of spaghetti. And similar to the beads, they ate what they could, but they push out a lot of what they want. You see those black fibers being pushed out through the front? But sometimes they'll even try to eat what they're rejecting. So they're not very picky, but we found that size tends to be an issue for them. And then finally, oops, what about those sea grapes that I told you about? They actually are really, really simple. They pull particles, they pull water in through here, which is a siphon. They catch it in this basket, and then it just gets twisted up and put in their mouths. And then it goes through their, what's called a linear digestive tract. It's just a straight path. And they spit out whatever, they ingest whatever they're gonna, or poop out whatever they want through the green arrow. But they are able to reject things. So say you gave them too much food, or too many large particles, they would contract that basket and push all the water back out where that red arrow is going. But pretty much they eat until they're full. So let's talk about some experiments that I did. These pictures are really microscopic. So they show the tiny beads and tiny fibers that I hand cut so that I could feed them to these animals. I always put my fibers and beads into seawater 3 days before I give them to the animals so that they're at least coated with things that they would be used to it being exposed to in the environment. And I did a bunch of size comparisons. So I gave them 2 different types of fibers, nylon fibers, which it was upholstery string. So what you would use to sew up your couch, those are the black fibers of 3 different lengths. And then I gave them polyester fibers, which is the tiny thread that you would use to sew up your jackets, the thinner kind, of 3 different sizes. And then I did comparisons. So if you give them the smallest of both those fiber types, what do they do? And if you give them 2 really small beads of different plastic types, what do they do with those? Can they discriminate between, can they tell the difference between plastic types? And so this is what the experiments look like. I put each animal in a jar. These mussels and oysters I actually attached to popsicle sticks. And unfortunately, I did not get to eat all of the popsicles, but I did use some of them that I had eaten from just for fun in a separate thing. And then I glued the snails and the sea grapes with some super glue to little plates. I offer them those different types of plastics, and I give them food, of course, so that they're happy and we can see how they would handle these things in the natural environment. And then I offered them plastics for about 2 hours, gave them an hour to decide if they wanted to spit anything out. And then I took the jars and I collected poop. And I collected whatever they spit out, whatever they didn't want. And you can see that they look very different. So the picture on the top is what mussel poop looks like with plastic fibers in it. So those are some nylon fibers, that thick upholstery string that you would use to sew up your couch. That's what that looks like in the feces. And that means that they ate it and pooped it out. So I can tell what they ate based on what I find in there. And then you can see the snot wrapped around the plastic fibers on the bottom. So that's what we were talking about, that pseudofeces. So that's what they don't want. They'll ball it up and reject it. And so then I counted how many fibers were in any of those, in the feces and in the pseudofeces, after that 3-hour period. And then after 2 days of just eating normally, how long did it take to get out of their systems? And what we found is that they reject particles based on size. So if you look at the bottom here, can you see my my mouse? Oh, yeah. Okay. So if you look at the bottom here, the smallest particles, the medium size, and then the largest ones, you can see that the larger the particle is, the more likely they are not to eat it. So they'll spit it back out. But we didn't find that they had any preference between two different types of plastics, whether it was a fiber or a bead. They ate pretty much whatever we gave them that was small enough for them to eat. And then I made this little radar here to say, like, if you were to go to a restaurant with any of these animals, how picky would they be? And you don't want to go to the restaurant with an oyster because it's going to call the manager. It's going to need to speak to the manager about what's in its food. But if you wanted to just go and eat everything, I would definitely call a sea grape because they are not very picky eaters. And then just a little bit of what the major takeaways were. So how do we use this information? Well, we can't really use any of these animals to monitor microplastics in the environment, because either they reject the larger ones, or whatever they do eat, they actually poop it out really fast. Within less than an hour, most of what we gave them was already out of their systems, and I was sorting through it on a microscope. And then oysters are definitely the pickiest, and sea grapes were definitely the least picky. So it's kind of what we expected, but it's good to know that you can't use these animals to monitor microplastics, and we need to find a better way to do that. Okay, so this might have you saying, okay, cool videos, but what does this mean for microplastics in our waterways? And these are the numbers that are based on research that was done on dust fallout. So while you're eating your dinner, how much dust ends up in your meal, and what you could be exposed to from a plastic water bottle that you bought on your way to work or on your way to school. And you can see that there's a lot, thousands to millions of particles that you could be exposed to each year from these sources. And then now, this is what we're seeing in oysters and the surrounding water from a bunch of different oyster farms that I sampled in Long Island Sound. And the numbers are really low. So it's like mostly 0, but the most we found was 8 actual microscopic tiny little particles in any oyster. And that would mean that at the most, you're exposed to less than 3,000 particles in a year. If you ate one oyster every single day, which I don't think anyone recommends that, but you should definitely eat oysters. They're really good for you and have important minerals. I think they taste like sea snot. I wish I liked them. But when you look at what's in the water, you can see that it's less than 2 particles in any liter of water. So that's pretty big. That's like this much water. And so that's great news for Long Island Sound. But it doesn't help us in the long run because we know that more waste is being produced and everyone's using single use plastic and it's hard to avoid. So all of that is ending up in our waterways eventually. But we can help take action. And isn't that what Blue Schools is all about? We want to do some beach cleanups to reduce the number of microplastics in coastal waters. This has actually been scientifically proven that if you clean up what you find on the beach, there will be less microplastics washing back up on your shores. And we know that happens because of what breaks down on the beaches, because they're getting beaten down, the sun's beating down on those plastics, so it helps them break down faster. So the faster you can get there and clean them up, the better. Just raise awareness around the industry, because the more plastics that are produced, the more of a problem this will be. So try to avoid using a plastic straw if you can at a restaurant. It'll make you feel better, and it'll be better for the environment to change the way that you look at plastic and use it in your daily life. And of course, for teachers, ocean literacy is always a priority. Helping everyone be aware, especially this group seems to be doing an amazing job. So appreciate your efforts, and don't forget to eat your oysters, but don't get them in like the desert. Make sure you're on a good beach town. And of course, I just want to say none of the work that I did would be possible without help from a million different people. And so I just wanted to throw some names up here and say thank you to everyone who helped me. And I'll answer any questions that I can.
Thank you so much, Kayla. That was super interesting and love the videos, especially. It's really special to get that inside view with those cameras. So we do have a couple questions already, and I'm going to encourage our other students to put some questions in as well. One group wants to know a little bit about nanoplastics. Did you study those at all?
So I haven't looked at them because they're so tiny that it's really hard to do. And some people can't even figure out how to really analyze them because they're so small. The microplastics are actually really hard to get out of animals and water. So to go even smaller than that is a challenge that people are working on.
Thank you. And do you have any thoughts on whether the microplastics are harming the oysters or mussels or any of those animals at all?
So I don't think so. We would need to do sort of a chemical analysis, but in terms of it being an actual particle, like I said, it goes through their systems really quickly. So even if they do eat it, which they don't eat a lot, I mean, most of the oysters that I looked at had nothing in them. But if they do eat it, it's one or two and it comes right out of their system. I think that would be more interesting to look at with nanoplastics. But again, that's difficult. But at this point, I wouldn't be worried about the safety of oysters.
Great. So we have a few questions like physiologically about oysters. So I'll give you all of them and let you answer. So first of all, how big do oysters get? How do they breathe? And how do they reproduce?
How do they breathe?
Yeah.
Okay, so they get pretty big. So if you're harvesting them to eat, you're gonna end up with an oyster that's about this size, which that's my hand. I have tiny hands, but a little bit smaller than my hand. But they can get pretty big. I've seen oysters that are like this big. They don't stop growing, so as long as they're alive, they'll continue to grow, which is a cool feature about oysters. The way they breathe, they use those gills that they actually use to eat too. Imagine if you could eat with your lungs. That's pretty cool. So they can breathe through the water. They like exchange oxygen with the water in their gills. And then what was the final question?
How do they reproduce?
Oh, that's a fun one that I wish I had a picture for. So oysters can actually be, well, a lot of these different animals can be male or female throughout their lives. They can change. But what they'll do is they'll release their gametes. So if it's a male, it's sperm, and if it's a female, it's eggs. They'll release it into the water, and then those will find each other in the water and form what's called a larvae. So it's just like a single cell. And that single cell has to grow and grow, and it'll eat what's in the water, and then it'll find a home and it'll land on other oysters. They tend to stick on top of each other, and it'll grow a shell and turn into an oyster. So yeah, they do actually swim around when they're little babies.
And we have some career questions. So, first of all, do you have fun doing your job? And also, how did you decide that this was what you wanted to study?
So I do love my job. This is work that I did to get into my career. I was still a student when I was doing all of this hard work. But I really liked research because you got to learn from your mistakes. One of the things about research is that everything's going to go wrong, and you're going to have to be persistent and decide that you're committed to figuring out a solution to that. I got into it because when I was little, I loved the ocean. I always had a little shell book with me, trying to figure out what shells were on the beach. I thought I was going to work with dolphins, but then I went to college and I got to do research with professors there. Different teachers took their time to make sure that I could figure out what I wanted to do. And I actually started working with slugs, which is very different from dolphins, and found my way into shellfish. And I think it's really important. Aquaculture, growing these and feeding people, is a great way to live because it's very sustainable. We can keep doing this for a really long time. And now I work for NOAA, which is in the federal government, and I get to interact with classrooms like yours, and I get to talk about how important education around the ocean is. And yes, I really enjoy it.
That's great. We have a question about beach cleanups. Is it better to use big machines like tractors to clean up the litter, or does that make more pollution than it's worth?
Ooh, that's a good question. I am not a beach cleanup expert, but I will say that I found that the manual way is also very satisfying and probably more effective, because if you're looking for something really tiny and you don't want to take all the sand, you don't want to completely disrupt the beach, which is its own little ecosystem. There's a lot of things living in the beach and the sand. I say go by hand and go pick it up, and or get a sifter, and you can sift there and sit there and build a sandcastle and sift your sand and find plastics. Sounds like
So,
a fun day to me.
yeah. So beach cleanups are always more fun than you think, actually, picking up garbage. So a couple other questions about oysters. First of all, like, why don't all oysters look the same?
Oh, so it's just the way that they grow. So they do kind of look like rocks, right? But oysters, because they, are free swimming and they'll settle wherever. If you land and you cement, they have like almost a cement that they make to sit where they're going to be the rest of their lives. So if you make that cement on another oyster and you're growing around each other, you're going to just grow whatever way you can. So they always end up in weird shapes and forms, which if you look at like the oysters on the half shell here, if you farm them, they work to make the oysters all evenly sized. So they won't grow the oysters on top of each other. They'll grow them in little racks. Here, I actually have a picture. So a rack like that we're pulling those animals out of, they'll grow them in those racks and keep them the right shape, and then get them to market the second they're the size and shape they want.
Very interesting. And I don't know if you said this before, but like how you said that oysters will keep growing. What is the lifespan? We had a couple of classrooms ask us how long oysters
Oh,
live.
that's so funny. I don't think I know the answer to that question. I think they can live a pretty long time. I want to say 10 years. They just, I was going to say metascallop. Well, a metascallop shell that belongs to ones in a lab. But yeah, I don't know. That's a great question.
Yeah, that is a good question. And similarly, like so what kind of water do oysters prefer, and where can we find oysters in the world?
So oysters are all along the shore. They like something hard to grow on, which is why if there's nothing else but other oysters, they'll land on those other oysters. But they like rocks and hard bottom, and so they'll grow on top of other shells or the rocks, and it's all along the coast. So if you ever go to the beach and you see that the tide, the water changes, right? So the tide comes in and out. So sometimes the beach is shorter, sometimes water's receding. And when sometimes when the water retreats, the oysters will actually be out in the air, but they can live with their shells sealed. So they actually do really well in really shallow waters.
And someone
So
else
you'll
wants to
find
know
them.
how we can tell the difference between a male and a female oyster.
Oh, that's really hard. I can't do that.
Yeah.
You'd have to do some science, some experimenting.
Do they change? Do
They
they change
do. They change
genders?
sex
Yeah.
throughout their lives. I think they start as male and then go female as they
Okay.
get older.
Interesting.
And so do the
Um,
snails. You know those snails that I showed you? Well, let me give you a little fun fact. So this stack here, the one on the lowest is a female, and then the ones on top are all males, so that they can reproduce together. And that's how they find pairs. So they build these stacks, and then if the one on the bottom dies, the next lowest one will become a female.
very interesting. And we have a
Yeah.
couple more career questions. So a few folks want to know how long you had to go to school to become a scientist, and how many years it took you, and that kind of thing.
So for me personally, I went to school for a really long time because I love learning. I did my bachelor's, which is the 4 years of college that most people do. And then I went home to Long Island and I did 2 years of school for a master's. And I could have stopped there and gotten a job where I'm working now, or in a lab work I've done to do science. You could do that at any of those stages. But if you want more money, you work a little bit, you go for school a little bit longer. So then I went for this work, I was there for 6.5 years.
A long
So
time
a
to
lot
go to
of
school.
schooling. Mm-hmm.
Seems like it's worth it. Um,
Yeah, I
we
think so.
we also have a few questions about how some of these different organisms are related, like who are oysters related to? Who are sea grapes related to? Can you give us a little insight on those?
Yeah, so oysters and mussels are considered what we call bivalve mollusks. Where did I put that? So I put them in a box together because they are more closely related than the other animals. But they're all the oysters, mussels, and those snails are all considered mollusks. So they're not directly related, but they have like further cousins. An oyster would be more closely related to a mussel because they're bivalves. And then sea grapes aren't really related to either of them. They're in their own separate grouping, which is called the tunicate. And yeah, so they're sort of related, but they all develop these mechanisms for filter feeding separately throughout their life, throughout evolution. Yeah.
Interesting. And do oysters make pearls?
These ones do not, but yes, a lot of oysters make pearls. And if you don't know how they make a pearl, it's so when they get something stuck in their shell between what's called the mantle, so that's the part that protects their organs from the hard part of the shell. If they get something stuck between their shell and the mantle, it'll be irritating. It's like when you can't get that collar, the tag in your collar is really bothering you and it's so annoying and you just want to cut it out. They can't cut it out. So what they do is they coat the thing that's bothering them in mucus and snot, and then they just keep doing that and keep doing that until it produces a pearl, which is so funny that they make something so beautiful just from being irritating.
Yeah. Someone else wants to know, who are the oysters' predators?
Ooh, they have a lot of predators, which is why I don't know exactly how long they live because a lot of things are trying to eat them all the time. So there's things when they're babies that will try to eat them in the water because they're nice and tiny. So other filter feeders would maybe eat them at that stage. And then when they get bigger, there's these snails called oyster drills, and they can drill a hole. The tooth we saw with the snail that's called a radula. That little tooth is sharp in drills, and they drill a hole through the shell and suck out the oyster from the shell. Sea stars will eat mussels. Oysters are a bit hard for them to get open, I think. And crabs love a good oyster. So yeah, they have a lot of predators, which is why they make their shells so hard and thick so that they can be as strong as possible.
And do you know if one type of oyster is better able to filter microplastics than others?
So throughout their life, they have different filtering abilities. So when they're little, they might filter faster, but they won't filter as efficiently. And then when they're older, they tend to filter more efficiently, but they can filter larger volumes of water, so they can filter more water at a time. So it just changes. But yeah, like humans, oysters have individual characteristics, right? Like any animal, so they're not all exactly the same.
Another person wants to know a little bit about the slipper snails and why do they try to eat the microplastic? Is there any nutritional value that they can get from that?
No, they're just silly little sea cows. They just don't know any better.
Yes, hard to tell. Sorry, I'm trying to catch most people. We probably have time for like one or two. Oh, should we put these animals back in the water if we see them at the beach?
If they're stuck to a rock and you see them on the beach, leave them alone. If they're starting to open, throw them back in the water. That means that if their shells are tightly closed, that means they're nice and safe and healthy. If they're like starting to open, that means they're stressed out. So you could put them back in the water if they're sitting there floating around.
Okay. Um, and what about like how do tidal flows help or hurt? Like, could they help to clear microplastics from the waters that the oysters are in?
I don't know that the tide would. I think that just depends on how much plastic is in the area. So, because the water is so dynamic, water can move and there's lots of currents within the water. If you've ever been to the beach and you've been pulled by a current ocean, the water. So, it's hard to really say whether or not a tide would bring or reduce plastic. It would just depend on what's there.
And one of our groups in Tennessee wants to know if there are freshwater oysters or just saltwater oysters.
There are. So there are some really cool freshwater oysters. My uncle, speaking of pearls, had to do a trip in China and he got to go snorkeling with the freshwater oysters and he picked us pearls himself for me and my cousins, which was really cool. So those are the types of oysters that will make those beautiful pearls.
That is really cool. Well, thank you so much, Kayla. This was really interesting. And thank you, students. We got so many great questions from you. We know you're thinking a lot and you're learning a lot. It was great to see you all. And thank you for paying such close attention. I know that can sometimes be really hard.
Thank you guys for coming.
Thank you, everyone. Have a great weekend.
Thank you very much. Have a good
Thank you for
weekend.
coming.
Yeah, I can put my email, I don't know where.
If you want to put it in the chat, or I can.
Yeah, there we go. I got it.
Yeah. Thanks, everybody.
All right. Thanks, Meg. I gotta hop to another meeting. This was a lot of fun.
Yes, thank you so much. Great job.
Absolutely. All right. Bye.
Bye.